All right, I wanted to make this recording just to, share some examples, but also how I personally remember the difference between the subsets of the real number system. So first off, you start off with natural numbers. And I just think of natural nature, that this is like the most basic ones. This is the first kind of numbers you learned about in kindergarten. You can count them on your fingers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Those are natural numbers. And then there's whole numbers. That's the second thing you learned. And when I remember whole numbers, I think of when I say the word whole, my mouth forms like the shape of an O or a zero. So whole numbers, I think of 0. So it includes all your natural numbers, 1, 2, 3, 4, and so on. But it also includes 0. And then after that, remember you learned about negative numbers. And that's integers. And this one's kind of a stretch, but when I see the word integers, I focus on the T. And that T, I realize I can make a positive and a negative symbol out of a T. So I just think of integers as positive and negative. So integers includes all your natural numbers, 1, 2, 3, 4, and so on. It includes your 0, but now it also includes -1, -7, -11, all just the negative numbers. After that, you progressed and you started learning about decimals and fractions. And so for that, those are called rational numbers. So this is rational. If someone's behaving rational, they're not acting crazy. They're thinking right, they're being rational. So I just think of those as not crazy numbers, but just like regular fractions and decimals. So it includes all of your natural numbers still in 0 and your negative numbers. But it includes fractions, whether they're positive or negative. It includes decimals that either end, like -0.67, or it could include some repeating decimals, but it repeats in a pattern like 0.33333333 or 0.12121212. You know what the next number is going to be. Those are all rational. So all of these numbers here, you start off with I'll use a different color here. You start off with your natural numbers, and then it expands because it includes 0 now. So all of these now are in your whole numbers. And then it expands. It includes now your integers. So it includes some negative numbers. And then all of these numbers are called rational. So there's rational and then there's irrational. So if somebody tells me that I'm acting irrational, they're saying I'm losing it a bit. I'm being a bit crazy. So irrational numbers are like those crazy decimals. If you put pi equals into your calculator, you're going to see it's a decimal that goes on and on forever, but you don't know what the next number is going to be. There's no pattern to be able to be like, oh, it's not showing on my calculator, but I know the next number is going to be a 4. Or if you put in the square root of 2 into your calculator, you'll see it's a decimal. It goes on and on forever. But again, no pattern. They're crazy. So numbers are either rational or irrational. The irrational and the rational numbers are all considered real numbers. So that's the last one. So real numbers is a giant category. It includes rational, and it includes a small set of irrational, crazy numbers, decimals that go on and on with no pattern. Rational numbers can be broken down into integers, whole numbers, and then the natural numbers are just the ones that you can count on your fingers. So the last kind of number I want to talk about is called imaginary numbers. So this is something new for Algebra 2 we're going to work with. So imaginary, I remember those because I just think of, it's just unbelievable. It's imaginary, make believe. It's something that you didn't think was possible. But there's this imaginary number that you're going to be using that we refer to with the variable I. And the imaginary number I squared, if you square it, it becomes -1. So I squared is -1. The square root of -1 is I, the imaginary number. So whenever you see a negative sign under a square root, whether it's -8, -9, -143, whenever you see a negative number under a square root, you need to remember imaginary. Because typically, remember, square root is saying what number can you multiply by itself and get whatever you're trying to take the square root of. Like, what number can you multiply by itself and get 9? 3. Because 3 times 3 is 9. They always have to be a positive number multiplying by itself to give you 9. If you multiply a negative number by itself, you get +9. So the number in here, everything squared, should always be positive, whether it's two positive numbers being multiplied together to give you +9, or two negative numbers being multiplied together to give you +9. But with imaginary numbers, you can have a negative number under the square root. So let's go through some examples of these questions. Some of you might have felt like you had an understanding of these different subsets, but the way the questions were asked kind of threw you off. So let's look at some of them. So first here it says these numbers 0, 1, 2, 3, 4 are called what? So even though there are some natural numbers in there, some like basic, all of these are not natural numbers. So I'm not going to check this off. You need to say, are all of them whole numbers? Remember, whole numbers is our natural numbers plus 0. So yeah, they're all whole numbers. Are all of these integers? Remember, integers are negative numbers. They include 0. It includes some positive number, or all the positive numbers. So this doesn't include negative numbers, but every single number in here is an integer. They're all integers. Are all of these rational numbers? Yeah, rational numbers include your natural numbers. It includes 0. It includes negative numbers. It includes fractions. So yeah, all of these are rational numbers. But they're not irrational numbers. Irrational numbers are those crazy numbers that go on and on forever, those crazy decimals. But these are all real numbers. Okay, so it would be those would be the ones that you would check. These, are they all natural numbers? Yes, natural numbers are just your basic 1, 2, 3, 4, 5, 6, 7, and so on, counting numbers. Are they all whole numbers? Can we say each of these is a whole number? Is 1 a whole number? Is 2 a whole number? Yes. Is 3 a whole number? Yes. Is 4 a whole number? Yes. So these are all whole numbers. Are these all integers? Remember, it includes negative numbers like -4, includes 0, but it also includes 1. It also includes 2. It also includes 3. It also includes 4. So yeah, they're all integers. Are these all rational numbers? Yep, rational numbers include decimals, includes 0, and it includes 1, it includes 2, it includes 3, it includes 4. These are not crazy decimals like whatever, so on. You do have no idea what the next number is going to be. It's not pi. It's not something like square root of 2, which goes on and on forever. but they are all real numbers. All rational numbers and all irrational numbers, those are what we call real numbers. How about these? Are these all natural numbers? No. Natural numbers are just counting numbers. Are they all whole numbers? No. Are they all integers? Yes. We have some just negative numbers. We have 0. We have positive numbers. All of those are integers. And all of those are rational. But they're not irrational, because irrational are those crazy decimals. But they are all real numbers. Remember, real numbers include your rational and your irrational. Okay, so with these, I'm going to pick out the irrational ones. The irrational ones are decimals that go on and on forever. We have no idea what the next number is going to be. Where this 0.11111, I know the next number is a 1. And the next number is a 1. And the next number is a 1. That's a rational number. Pi is another irrational number. You put pi into your calculator, you have no idea what the next number is going to be. But the rest of them, just a regular fraction. 3/4 is the same as 0.75. A negative number, 8. Those are all rational, regular numbers. Okay, let's look at some of these. It says, identify the sets as integers, rational numbers, or whole numbers. So it says, which of these terms can be used to describe each and every number in the set? Like if you look at this first one, natural numbers. Yeah, 1 is a natural number, but 0 is not a natural number. 3 is a natural number, but -6 is not a natural number. Whole numbers. 0 is a whole number, 1 is a whole number, 3 is a whole number, but 6 is not a whole number. Integers. All of these are integers. Positive, negative, 0. So it would be integers. So they're asking each and every one of them has to be, like for this one, are these all natural numbers? Yep, that's natural. That's natural. Natural numbers are just positive, regular numbers. These are all whole numbers. Also, 0 is a whole number, but positive numbers and then 0 are whole numbers. It doesn't have to include 0 in the set to say these are whole numbers. Whole numbers include all those natural numbers and 0. And then integers. Each of these is an integer. Integers are positive numbers. This is an integer. This is an integer. It also includes 0, if they gave us that. It also includes negative numbers. But it doesn't have to have a negative number and 0 in order to say that these are also all integers. Okay, which set is of integers but not whole numbers or natural numbers? So this is kind of confusing the way it's worded to me. They want to know which of these sets includes numbers that are all integers, but they are not all whole numbers, and they are not all natural numbers. So if you look at A, integers, remember, are natural numbers like 1, 2, 3, 4. Integers also include 0, and it also includes negative numbers. So kind of give yourself an idea, an example to understand what integers are. So A, are these all integers? Yep. Negative numbers are integers. B, are those all integers? No, no fractions. C, no, these are those crazy repeating decimals. If you put in your calculator, what does this equal? It's going to be a decimal that goes on, and you don't know what the next number is. Negative square roots? No. And then E, are these all integers? So yes, they are all integers. This is an integer, this is an integer. These are all integers. But now we need to look at them and see which of these, A or E, is not whole number, not all whole numbers, or not all natural numbers. So if I look at this, are these whole numbers? Yes, these are whole numbers. Are these all natural numbers? No, because that includes 0, so it's not all natural. How about this one? Are these not all whole numbers? Yeah, I can't say this is a whole number. This isn't a whole number. This isn't a whole number, because whole numbers can't be negative. This isn't a natural number. This isn't a natural number. And this isn't a natural number, because natural numbers can't be negative. So the answer for this one is A. Which set is of whole numbers but not natural numbers? So which set can I say, these are all whole numbers? So let's look at it. Remember, whole numbers includes 0, and then it includes positive counting numbers. So E includes 0 and then just some positive counting numbers. So this is all whole numbers. But I can't look at it and say all of these are natural numbers. No, because natural numbers does not include 0. So the answer for that one would be E. Which of these numbers are rational numbers, but they're not integers, they're not whole numbers, and they're not natural numbers? So I can't look at it and say this is all integers. This is all whole numbers. This is all natural numbers. So if you look at each one, for A, these are rational numbers, but can I look at these and say that they're not integers? No, those are integers. Integers include positive and negative numbers. So it's not A. How about B? Regular fractions, they don't repeat in some crazy way. So these are rational numbers. Are these integers? No, integers, remember, are negative numbers. It includes 0, and it includes positive counting numbers. So these are not integers. Can I say that these are all whole numbers? Nope, whole numbers just include 0 and 1, 2, 3, 4, and so on. And then are these all natural numbers? Nope, natural numbers include just the counting numbers. So the answer for this one is B. Imaginary numbers. Remember, imaginary numbers are the ones with a negative number under a square root, because you wouldn't think that can happen. That's like unbelievable. That's what the imaginary number does. And then irrational numbers. Remember, irrational numbers include those numbers that go on and on forever, where you don't know what the next number is. If you look at it and you're not sure if it's irrational, you want to put it in your calculator and see what it equals. Put it in your calculator and press equals. Put it in your calculator and press equals, and see what that decimal looks like. That's it, guys. I know these were a lot of examples, but I hope it clarified a bit, and let me know if you have any other questions.